All right, we're going to do two more sections in chapter 2. We're going to do 2.6 and 2.7. And both of these sections have to do with inequalities. Now, we've been talking about solving equations where we have an equal to sign. But what happens if they're not always equal? Because a lot of real world situations translate to inequalities. They don't have to be equal. For example, a student might want to register for at least 12 credits. So I can equal 12 or I can be more than that, right? Greater than or equal to. Or an elevator might be designed to hold at most 2,000 pounds. We can hold 2,000 pounds or less than. So maybe these things aren't always equal, but they translate more into inequalities. So let's talk a little bit about inequalities. Before we actually start to solve inequalities though, the first thing I want to talk about is how to read an inequality properly, because that's really important. If you look at this first one up here that I gave you, remember we talked about inequalities in a previous section, where remember the alligator wants to eat the bigger number. So when my inequality looks like this and it's facing the x, we always read it from left to right, and it's always easiest to put the variable on the left so that I can read this x is greater than 3. Well, if x is greater than 3, what can x be? X can be anything bigger than 3, so 4, 5, 6, 7, 8, and so on. But it's easier to read it that way when the variable's on the left, and then you can read the inequality sign from there. X is greater than 3. Look at the next one. See if you can read that one properly. Y is less than or equal to -5. So I might ask you, what can y be? Well, if y is less than or equal to -5, I can be -5 or -6 or -7 or anything that's less than -5. All right, these last two are a little bit tricky. You notice that they're written out of order. And so for me, it's much more helpful to read it from left to right and making sure the variable's on the left side. So if it's written like this, we can always rewrite it. I can take this problem, and do you notice the alligator's eating the x? So when I flip it, the alligator still needs to eat the x, right? And so now I can more easily read this as x is greater than 4. Try the next one. I can rewrite it. The alligator's not eating the x. And I can read this now as x is less than or equal to 7. A little bit easier to rewrite it when it's in that order. All right, let's talk about example number 1, where we're looking for solutions of inequalities. And how do I know if it's a solution? Well, example number 1 says determine whether the given number is a solution of y is greater than or equal to 6. So if y is 6 and I substitute that in, is 6 greater than or equal to 6? Well, yeah, it's equal to. So that works, right? 6 or bigger than. And so 6 is a solution to that inequality because it's true. What about -4? If I substitute in a -4, is -4 greater than or equal to 6? Well, no, it's less than, right? So that would not be true. So -4 is not a solution to that inequality. All right, the next little thing we're going to talk about is graphing inequalities. We can graph inequalities with one variable on a number line. And so we can put our number on a number line and then we can graph it from there. Now, parentheses are used to indicate endpoints that are not equal. So if I just have a less than or greater than, I'm going to use a round parenthesis. Or brackets, squared off brackets are used to indicate endpoints that are included. So greater than or equal to 5, less than or equal to 4. I would use a squared off bracket. That will tell me if it's equal to or not. All right, example number 2 says graph each inequality. So the first one says x is less than 2. So on a number line, I'm going to put my 2. Now it's less than, not less than or equal to, so I'm going to use parentheses. And which direction is less than? Well, it's to the left, right? So I'm going to draw my parenthesis by my 2, and then I'm going to draw an arrow to let me know that I'm going less than 2. I don't want to do brackets because I don't want to include 2. I just want to be less than 2. Some books and some teachers, instead of using parentheses and brackets, might use open or closed circles. So I'm going to show you that too. If it's not equal to, we're going to use an open circle and then do an arrow indicating that it's less than 2 by drawing an arrow to the left. So an open circle or a parenthesis are the same thing. Let's look at B. B says y is greater than or equal to -3. So on my number line, I put -3. It's equal to this time, so then I want to use a bracket, and then I want to be greater than. So I'm going to draw an arrow to the right. I'm going to use a squared off bracket now and put an arrow to the right, indicating that I can equal -3 or be bigger than -3. If I was using circles, dots, or closed dots or open dots, I would use a closed dot to represent that I can equal -3 and then be bigger than it also. Anything that's greater than or equal to -3. All right, C is a little bit different. This one is a compound inequality where we have two inequalities at the same time. A little bit harder because we have that compound inequality. So what you might want to do is read each part separately. Look at this side. This side says x is less than or equal to 3. This side, remember if it's backwards, we can always flip it. So if I put the x first, remember the alligator is eating the x, so it should still eat the x if you flip it, and then -2. So now if I read it, I can read this one that says x has to be greater than -2, but x also has to be less than or equal to 3. So in this case, x is greater than -2, but less than or equal to 3. So let's put our numbers on a number line. -2 would obviously be first on the left side, and then 3. On the -2, I want to be greater than, but not equal to, so I'm going to use a parenthesis. And then I want to shade to the right to indicate greater than. On the 3, it says less than or equal to 3, so I'm going to use a bracket, and then I'm going to go to the left to indicate less than. So it looks something maybe like this. And so what that means is any number in between here should work. I can include 3, I can include -2, but any number in between, including 3, should work in that inequality. Pick a number. I don't know, 0. Is 0 greater than -2? Yep. And is 0 also less than or equal to 3? Yep. So 0 works in both of them. Any number in between, including 3, should work. If you were using your circles, open circles or closed circles, it would look something like this, where you have an open circle at -2, a closed circle at 3. It doesn't quite look like it's all the way to 3, so make sure that it looks all the way to 3. I don't know what happened there. And then anything in between, including 3, but not including -2, and then anything in between. All right, so if I've given you an inequality, you can graph it. But what if I asked you to go backwards? What if I gave you this problem right here? What if I gave you the graph? Could you write me an inequality from the graph? So it looks like here, these are supposed to be round parentheses, and then my arrow is pointing to the right. Could you give me an inequality that represents this graph? It doesn't matter what variable you use. Typically we use x's because that's the most common, but any variable would work. And did you say x is less than or greater than? Greater than, good. And did you say equal to or not equal to? Good. So x is greater than -4. I know that it's not equal to because of the parenthesis, and I know that it's greater than because it's going to the right. So making sure your alligator eats that x because x is greater than -4. All right, maybe some of you have also seen this trick or you've recognized it as you were doing it. You notice the arrow of your alligator points to the left, and my arrow of my graph also points to the left. As long as you have it written like that, that should always work. Again, if you notice that your arrow is pointing to the right, then we should be able to take that arrow off, and it should also point to the right on your graph. Kind of cool, huh? But again, that only works when it's written that same direction, so be careful. So again, if you notice this one, we wouldn't put it to the left because it's not written in the right order. But if you write it in the right order, it works. Pretty cool, huh? So just another cool trick to help us remember which direction it's going to go.